Hey guys, welcome. Schlegel here with a tutorial on how to set up and construct a 3D print. So I've got an example of something cool I just made today. It's called a Flexi Frog. Found this design online. And so I'll be showing you how to take a design that's already online in this video and turn it into something real. So we will also spend some time this summer creating our own designs, but in this case, we're just going to go off of an existing design. So with that, I'm going to close out this section of my video here, and we're going to take a look at what it is that we are going to be constructing today. So I went onto this website, Cults 3D, and I'll share this website and a couple others with you in our class. But it's got some pretty cool stuff that you can get for free. Like this one is free. This one was free. There's also a bunch that you have to pay for, but I think that this Flexi robot right here is pretty cool. So I downloaded this file and saved it on my computer. And what we need to do after downloading the file and getting it onto the computer is we have to open the Dremel Digilab 3D slicer. And so you should have an icon that looks like this on your computer if the app or program, whatever you want to call it, has been installed. And once we get in there, what we're going to be looking at is opening the file and finding it's called an STL, is going to be the file format that we downloaded or we want to make. And you can see that I've done a wolf for Wapato, Wildcat for Toppenish, Spartan for Granger, and a bear, a grizzly for Sunnyside. We'll be raffling those off sometime here soon. Or it's already happened actually by the time you'll be watching this video. So we are going to be building the Flexi Foco bot today. So we're just going to click the file. You can see a little small image of the robot there, and we will click open. So after we click open, it looks kind of morbid. It almost looks like the little robot's dead. We've got the robot laying here on our build plate. And this kind of grayed out piece here at the bottom is the actual build plate where the printer builds stuff. And so we are limited in the size of the objects we print by how wide our build plate is, by how deep our build plate is front to back, and how tall our 3D printer is inside. So from up here, this top level here, down to the floor there. And so you can see our build has to take place within this kind of rectangular prism here. And so on the right here, we see a ton of different customizable, I don't know what you want to call it, settings. My best advice is don't mess with those. I would only ever mess with these two up here. So the material we'll be using today is going to be PLA material. There is also other material like Eco ABS, nylon, PETG, PLA, etc. And I think what's in there now is actually PETG. Most of the stuff we're going to be using is going to be PLA. So two things: you want to make sure you select the correct material. Again, most of the time it's going to be PLA. And then you want to select a build profile. So I would just use these pre-done profiles instead of messing with all these settings down here. And it would be a real jerk move of you to print something in ultra quality. And we'll talk about why in just a moment. But if I was, my recommendation for this summer is that unless we have a ton of time on the printers and there's not a lineup, which I anticipate there's going to be, I would stick with medium quality or low quality, just because these will print much faster. So this will print the fastest, this will print the slowest. As the quality increases, the time it takes to print it also increases. Because, for example, if we go from medium quality, which is 0.2 millimeters, to high quality, which is 0.1 millimeters, the time to build it will basically double, because for this, each layer is half as thick as it is for this. And as you may have noticed when we had the little frog up here earlier, that was done on medium quality, and you can barely even see the layers, the lines of the layers anyway. So again, just kind of closing this out, I would recommend that you sort of leave this as it is, stay recommended here. PLA most of the time. Medium quality is a pretty good one. I would kind of stick with that. If you want to change it, please talk to myself or an RA or one of the 3D printer leads. And we can see here in these kind of more basic settings, we have 0% infill, which would make it totally hollow. That would make it almost it would print faster, but it would be very weak. It would be able to be crushed like an egg. 20% infill will make it pretty darn strong. And so unless you're doing something structural that's supposed to hold a lot of weight, anything like that, all of the 3D prints I've done so far have been 20% infill. You could go up to 50% infill if you're needing a lot of strength. Again, if you're going to change that, please talk to a 3D printer lead, an RA, or myself. And 100% infill will make it totally solid. These will use a ton of material compared to the 20%, and you won't gain much strength by doing that. So please, again, unless it's a very specific application, stick with the 20% infill. So again, for my build, I've got PLA. I'm actually going to end up changing that to PETG because for this particular one, I do have a PETG filament in there. And it looks like it doesn't want to change, which is kind of weird. Okay. Oops. And I don't want it to be EcoABS. So again, most of the time it will be PLA. We'll stick with medium quality for most of the builds, and we'll stick with a 20% infill for most of the builds. I am going to change it back to PLA for now just because it's easier to see on the build plate. And so this is showing up as blue. You can choose any color to print with that you want. It could be clear, which is what the PETG is. It could be black, it could be green, it could be orange, it could be whatever. In this instance, it's always going to show up on the build plate in this program as being blue. So what you will notice, though, is if I click it, I see these three axes now. I have a green front to back axis or a y-axis. I have a red side to side axis or an x-axis, and have a blue up and down axis or a z-axis. And if I click that, you'll notice that over here, these buttons lit up. If I don't click that, I don't have access to any of these buttons. So I want to click my shape, and we'll first talk about moving it. So I can grab it. If I'm in the move section, I can grab it and move it around the build plate. Most of the time I want it to be just centered in the build plate because it's going to be the easiest thing to do. And you'll see as I move it, if you look here at these numbers, they're changing. And what that's doing is it's giving me a reference point compared to the origin. And so if we were to think about like a graph and we think about this right here as the origin, that's 0, 0, 0. And when I move around, those numbers change because I'm not at 0, 0, 0 anymore. And you'll notice that my model has changed to be this kind of zebra stripe instead of the blue. What this zebra stripe is indicating is, hey, this is not printable because it's hanging off of the build plate somewhere. So here it's hanging off of the right side, here it's hanging off of the front and the right, here it's hanging off of the back. But if I get it back inside, it will turn blue again. One thing we want to make sure is that our images are on the build plate and they are fitting. We also want to make sure that we have good build plate contact. So we want to make sure that when we look at it like this, that the most of the model as possible is touching the build plate. Okay, that's it for move, and an easy way to get it back to the origin. Like I had a print that I did the other day that for whatever reason popped up over there. And I was like, what are you doing? The easiest thing to do is just going to be to come over here and change all of these to 0. Similarly, if you have a model that is floating in the air, I'm not sure exactly, let's see if I can get it to do it. I raise it up off the build plate. Now it's floating in the air. You can see that my axes have changed. Oh wait, no, it's not floating, is it? Crazy. Okay. Now it looks like it's floating, but it's not. If you are floating, or if you are off the build plate, or if things are not good, the easiest thing to do is going to be to go back to 0, 0, 0. Okay? So that will place it back in the middle. Now, the next thing we can do is we can change the scale. We can make it larger, we can make it smaller, we can do all kinds of things. And so right now, the longest measurement on this thing is 162 millimeters. It will be 162 millimeters from the top of the head to the bottom of the feet. And I can change that. And if I change that, I want you to notice that these others change at the same time because it's going to keep everything to scale. So in math class, you might have talked about scale factor. So I changed that from 164 to 200. Watch this, 74 and 27 are going to change also when I hit enter. So I made it bigger by doing that, okay? I could also make it smaller. A little micro robot. I think for this build, I'm going to go ahead and stick with a height of 200. I could change my mind though if I feel like it's going to take too long to print it. And so right here later, it will tell us how long it believes it will take to print it. If that's going to be too long, I'll make it a little bit smaller just so it doesn't take forever. All right, so that is moving and scaling. The next one is a super important one, and I'll talk about why. If you haven't paid attention for any of the video yet, please pay attention to this piece. One of the things we have to deal with in this sort of 3D environment is the fact that the 3D printer can't print in mid-air. And I'm actually going to pause this video for a second and show you an example of what happens when the 3D printer is trying to print in mid-air. All right, so I'm back with an example of what will happen if you try to print something in mid-air. So these two images, this one here on the left and this one on the right, are actually the same 3D print. Now, what ends up happening is there's a setting on the 3D printer that says if the overhang is at an angle that is steeper than 60 degrees, it needs what we call support material to be able to print that. For instance, this jaw of the grizzly hanging down here on the left, the 3D printer can't start right here and just start printing because there's nothing to catch the plastic when it melts out of the nozzle. And so for this whole front part of the grizzly, up under the armpit and everything else, the 3D printer has to put in place what we call support structure. Support structure is bad for two reasons. Well, three. Number one, it uses material that we're eventually going to break off and just throw away, so it's a waste of material. Number two, it adds to the build time because it takes a long time to construct these scaffolds that come up all the way to the chin of the grizzly. And the third is that it's a real pain to break off. And so I actually hurt my fingers trying to break this stupid stuff off of here. I have to use scissors and pliers and all kinds of things to break the support structure off. The other piece is breaking the support structure off damaged some of the top teeth here on this build because they were small and fragile. So one of our goals when we are setting up a 3D print is going to be to avoid having a support structure as much as possible. Now, the way that we're going to see support structure in our program here is it's going to show up as red spots. And so what I need you to notice though is that if we pull this up like this and look underneath, we can see that there is a ton of red there. I wonder if I can zoom in here somehow. That's strange that I can't. Okay, so there's a ton of red there, but that's where the back of this robot is touching the build plate. And so that's okay. You can see as we spin it here that the red is all down at the build plate, except for just a tiny bit right there, it looks like right here in his hand, or his, I don't know, elbow, whatever you want to call that. So for the most part, this is set up to print pretty good. There's not going to be much support structure. I did say that rotating was going to be a big deal. And let's see what happens if I rotate this for him to be laying on his belly, or on his side in this case, instead of on his back. So if we look under the model now, see all the red that is up in the air, like the side of his head, the side of his chest, the sides of both legs right here. What the program is telling us is that this would need, in this orientation, to provide support structure for all of that. So I'm going to go ahead and hit prepare right here and see how long it estimates that it would take to construct this model and how much material it would use to do that. So while that's slicing, again, if we look at this, there's tons of places, like the whole thing is painted red in the air. We want to avoid as much red in the air as possible because, again, that is adding support structure, it is wasting material, it's a pain to break it off, and it adds significantly to the build time. So while that finishes slicing, I'm going to pause because I don't have anything else to say while I wait. All right, and so that finished, and we can see that it's estimating that it's going to take 10 hours and 21 minutes and use 120 grams of material to do this. And so I'm going to write those numbers down: 10 hours and 21 minutes and 120 grams of material. Plus, we're going to have all of this ridiculous stuff that we will have to break off. And in some cases, like the Grizzly, it's unavoidable. It's impossible. That was the best that I could do. That was the best orientation I could find to have the least amount of scaffolding or support material. So now I've laid the object back down on its back, the robot here, and we can see that again, there's no support that is hanging. There's nothing that's going to need to be broken off later. And so we're going to hit prepare again, and we're going to see the impact on both the time and the amount of material here. And as I did before, I will pause while that does that because it's going to take forever. Okay, and it's done. We're back. And so we can see now that the build time is 5 hours and 54 minutes. So we shaved almost 5 hours off of the build time just by laying the robot on its back instead of on its side. And we went from 120 grams of material down to 67. So we saved about 53 grams of material as well. So this is going to be cheaper. It's going to use less material. It's going to get done about 5 hours faster. And so how you orient your project or your build on the build plate is a big deal. Please take the time to experiment with different orientations and find the one for your build that is going to work the best. And again, the way that you can tell is by how much time is it going to take and how many grams of material is it going to use. That's usually probably the best indicator that you're finding a better or a worse orientation for your build. So I totally believe that we have the best orientation for this build now. What I'm going to do is our 3D printers came with thumb drives. And so I have put that thumb drive in my computer. I'm going to save this image to the removable drive. And I'm on a Mac, so I do have to eject it. And now it's going to be ready to take my thumb drive over to the 3D printer and make this thing a reality. Okay, so we've got our 3D printer and my little workstation here. I've got the thumb drive out of my 3D printer, or sorry, out of my computer. I'm going to put that into the 3D printer now. And the 3D printer will automatically sort of pick up that there is a USB drive in there once we hit this button that says build. So I get the build button and I have the option to select the USB drive here. It's the one in the middle. And then all the stuff that is on that USB drive is going to be listed there. We can cycle through that list and choose what it is that we want to build. And so in our case, we are looking for the FocoBot. And so I see the Flexi FocoBot right there. Now, before I hit build right here, we need to be aware that there has to be a build plate in here before we can 3D print. And the build plate is actually this piece of glass right here. And what you'll notice is that my piece of glass is a little bit foggy. And this is because there's an old layer of glue on this build plate. And we're using just a glue stick like this. So it's okay to use the build plate repeatedly and just keep adding a new layer of glue each time that you do a print for a while, like maybe 4 or 5 prints or something like that. But once the layer of glue starts to get kind of thick, you definitely want to take this build plate to the sink, run some hot water on it, and wash off the glue and start with a new clean build plate. So again, the easiest way to get rid of the glue, you'll see it's purple right now. Once it dries, it will get kind of clear looking. When it's time to clean this build plate, we just take it to the sink, run hot water on it, and use this scraper to scrape all of the old glue off. It's totally okay for the glue to go down the sink. It is water soluble, but it's probably actually better to just go ahead and get it in the garbage. So now my build plate is ready. I've got glue on here everywhere that I think that the image is going to be printed. So we slide our build plate into the back like that. And then in the front there are two clips here and here. We just push down and those two clips will snap our build plate into place. Don't forget to put the cap back on the glue. So what I see right now is it's telling me that the nozzle is getting hot and the build plate is getting hot. And if I was to touch that build plate, it is really warm. It's probably not hot enough to burn me, but probably something you want to avoid touching is the piece underneath this glass, or even the glass now that it's been put on there. Definitely don't want to touch up in here where the tip is, because that's going to get to about 500 degrees. So safety, be careful when you're messing with the 3D printer. Really try to only touch the build plate, or in the case that you are changing filament. Over here on the end, you can see my roll of filament is in there that I just put in. And the other piece that's important to remember when you change filament, be sure to put this retainer on, otherwise your roll of filament will probably fall out and go rolling down the classroom. So there we go. Our build plate is warming up, our nozzle is warming up. There's a bunch of options here. The option that I want is I want to click the build option. And so it's pulling the file off of the thumb drive right now. It's copying the file. And now that it has the file, it's going to go ahead and run through a process of kind of a self-diagnostic. It's going to try to figure out, hey, is the build plate level? If the build plate is not level, we can adjust it with this roller right here and this roller right here. But it's going to do a test to see if the build plate is level, which will take it just a moment. I'm going to pause while it does its test. And so it's just finishing its test to see if the build plate is level. It is also preheating, it says here, so again the nozzle is getting very hot to about 500 degrees Fahrenheit, and the build plate is getting at least warm. Again, the build plate probably won't burn you, but the nozzle definitely would. And right now it's going to take it a while to get to the temperature it needs to get to. It's going to get to 250 degrees Celsius for the nozzle and 80 degrees Celsius for the build plate. So I'm going to wait for both of these to be filled up, and then it will start the print after everything is preheated. So it is just about done preheating. We are at 248 degrees on the nozzle, and it's preheated now. You can see the build plate is coming up. Looks like some of our filament leaked out a little bit, so I'm going to pull that away. That has not happened to me before, so it's a unique case this time. But we can see now that, I'm going to turn this light up so we lose the glare. But we can see now that the nozzle is kind of running around the build plate. What it's actually going to do, it's going to drop a perimeter around the outside of our build. And what that does is it helps with this thing called build plate adhesion. It helps the actual image that will be printed inside this perimeter to stick to the build plate better. And so this is a great time to talk about failed prints. And so a print fails if we don't have good build plate adhesion, which means that it comes unstuck from the build plate, because then the 3D printer is just trying to build on something that's not there anymore because it slid out of the way. And so it's important to make sure that we have the glue down on our build plate, because that helps with build plate adhesion. And it's also important to make sure that we have identified the correct filament for the print that we are doing, because the printer will change some settings internally based on the kind of filament that's being used. So back to our build really quick. You can see kind of down in there, let me open this for you. I would leave this closed during the build, but there is our perimeter, and it's going to finish that up and start actually building our little roboto here in just a minute. I'm going to go ahead and pause for now, close this. As I mentioned, having both the top and the front closed is a good idea during the build, just so our build doesn't get disturbed and so no one gets burned. And we'll be back to take a look at our robot sort of as the process goes on. Okay, our printer has been working now for about an hour, and so we're going to take a look at the progress that has been made so far. Spin this around, and we can see that it's interesting. What I thought was going to be a perimeter ended up kind of going through the head and through the arms. I think it's because we made the robot bigger than the original image, if you remember that from our thing. But you can see now that the robot's kind of taking shape. The entire bottom layer or bottom couple layers maybe, has been laid, and now we're going to be building vertically. So we're going to get some depth to this robot, and we'll be able to start seeing some features as the build goes on. It's saying caution, door is open, so as I mentioned previously, it's a good idea to keep that shut. We've still got about 5.5 hours left on this build. And we are a couple of hours into the build now. You can see the sort of honeycomb shape that is filling the inside of our robot. This honeycomb shape is a rigid structure that is strong but lightweight. Again, this is 20% infill. 50% would be about double that much material on the inside. Again, not necessary to go above 20% unless we're building something that is really going to be supporting a lot of weight or have a lot of torque put against it. We can see that our robot has some depth now, probably about 1/4 of an inch thick, maybe 3/8 of an inch thick. And so again, the way that this works is the 3D printer builds the object one layer at a time. So that's the purpose of the slicer, is to create all the layers that the 3D printer is going to create to make our object. And don't forget to shut the door. So our robot is gaining some depth. You can really see the sort of honeycomb pattern on the inside now. Again, 20% infill there. And we can see quite a bit thicker. Still got about 3.5 hours to go. So we've got our completed build here. And it finished up overnight. And so we can get the plate out by opening the front door or by opening the top door. I find the front door to be a little bit easier. There's 2 tabs, just like when we put it in, one right there and one right there that we need to release. And then it lifts up and comes up. So we've got our robot here that is completed. And there's a couple ways to go about getting the image off of the plate. In the instance of the Grizzly, it was very tall, and so it was easy to just kind of grab it and tap it or knock it off the plate and bust it off. And it was also very strong, so if you have things that are delicate and that kind of thing, you definitely don't want to be like grabbing and trying to break it off. The other thing is, with something like this that's fairly short, it's very difficult to grab it and pull it off. So we're going to take our scraper that we would use to remove the glue and that kind of stuff like we talked about previously from the plate, and basically kind of come at it at a fairly steep angle like this, and just kind of attack it with the scraper until pieces of the robot become not stuck to the plate anymore. And so we had pretty good build plate adhesion here. You can kind of see the outline of what was the robot stuck on there. And we've got a little bit of cleaning up to do. We have some of what I would call slag, like this extra junk right here that we need to just kind of pop off and clean our robot up. But I'll take care of that, and we'll be back with our dancing robot. Okay, we've got our robot here all cleaned up. You can see he is articulated. We can even get him to do the floss. So that's going to be it for this demo of how to use the 3D printer. Remember, safety first. Don't touch the nozzle. It's going to be hot. And be careful also with the build plate. It probably won't burn you, but will definitely get warm. Schlegel out. Schlegel was out, but now Schlegel is back because I forgot to show you guys how to change the filament in the printer. And so we're going to be changing filament anytime it runs out, anytime that or anytime that we want to change color and print something in a different color. So right now I just got done with our little robot friend, and so I've got this clear filament in there at the moment, and we are going to switch that over to a blue filament. I'm about to make a chariot for our robot Sphero, and the first part that I'm going to make blue. So the first step in changing the filament is to open the top like this, grab a pair of scissors, and basically just cut the filament kind of close to the print head back here. So then that will come out. This piece comes off the side over here, and you can sort of spool up the extra filament that was going into the printer and pull this whole roll out. So I will pause right now and say that if you are printing something and you run out of filament in the middle of the printer will just pause. So there's no reason to worry about, hey, I'm running low on the spool of filament, I should change it and throw away this little bit of extra filament that I have. The answer is no. Let the spool of filament run all the way out. The printer will pause, and then you can just put a new spool on, and that way we're not wasting filament. So that being said, I'm going to grab my blue. And you can see I put it in the retainer thing there, and it actually broke. So what we want to make sure we do is that we put this in to the 3D printer with a little tail of filament pointing toward the back. And in the back, let's see if I can get it so you can see it here. That little clear tube there, we're going to feed the filament through that little clear tube. So we'll unspool a little bit. The tube basically guides the filament up to the print head. Stuff's kind of sprungy, likes to bounce around on me. So now we've got it out here. We're going to pull this up, put our, some of my stuff came off the spool. We want to make sure that it's on the spool correctly. Okay, so we get that in there. And then we always want to remember to put this cover back on, because if we don't, it'll start printing. The whole roll of filament will fall out and go rolling down the room somewhere. So we want to retain that filament, keep it in there, so that's there like that. Now the next thing is going to be considering how do I get, one second, a little bit of camera difficulty here. How do I get this clear filament out and this blue filament in? Well, what we need to do is down on our control panel, we'll have the option that says filament right here. We'll click filament, and we're going to say change filament. So it's going to pull itself up to this front corner over here, and it's going to say, okay, cut the filament. I've already done that part. So the next step is it's going to heat up the nozzle and basically melt the existing filament out. And so I'm going to pause while it heats up because it tends to take a while. Alright, so I've moved the camera a little bit closer. It is just about done preheating. It's getting close. And what's going to happen when it is preheated is this is basically just going to melt through the hole. You can see it going down now. We're going to put the blue filament through this little feeder here in the back, this kind of black guide, and then straight down into the hole. So if you are not, if you're off by just a little bit, it's not going to go anywhere, but if you do hit it correctly, it will start to go down into the hole if you push it. So I'm pushing it right now into the hole, and you can see the filament that's coming out is still clear. We're going to keep going, pushing this filament in until we see the color change in the nozzle, or coming out of the nozzle. So, come on. Oop, I must not have hit the hole correctly because it doesn't seem like it even went in there. So let's try it again. Schlegel's having some difficulty. How about that? Let's see if I can fix it, and I'll be right back. Okay, I think I got it. So again, I'm just pushing it through, yep, until I run out of clear filament coming out, and I see a change over to blue filament like this. Now I know that I have got my blue filament ready to go. And I can pop that up into that retainer. I can either push it in through the back or snap it up in there like that. Either way will work. So we want to tell the control panel now that we're done with that part. So next. And press done when the new color appears. Actually, so you don't have to push it. I keep forgetting that step. It's actually going to feed through itself, and you can tell it, you can see the blues coming out. You can say, okay, we're done. The blue is definitely coming out. So sort of two ways to go about changing the filament or kind of initiating the process. You can push it in yourself, like I did to begin with, or you can remember to go to the third step and let the machine pull the filament through, like I just remembered right there at the end. I think that this might be my last how-to 3D printer video. We'll see if I forgot something else though. Schlegel Engineering. I lied. One more video. This time we're going to be talking about a heat gun. So 3D prints are made out of plastic, and so since they're plastic, they're very responsive to heat. And so if your print comes out and it doesn't quite do what you want it to do, and it just needs a little modification, like something needs to be bent or pressed in or something like that, a heat gun is a great way to do it. And I've been practicing just now on this thing right here, which is a phone speaker amplifier. And so what's happening in my case is that when I put my phone in here, it's covering about that much of the hole on that side and about that much of the hole on that side because it's pretty wide. And so what I'm going to do, or what I have been doing, is heating this up and kind of bending it to help my phone fit better down here. And I'm going to heat this joint area right here and this joint area right here and kind of bend these ears out a little bit so that I get more sound coming out of my phone amplifier. So I'm going to pause and put this little phone I've got right here into my recording studio stand, and we'll demonstrate how the heat gun works. So the heat gun, pretty simple, on-off switch. It's got a stand down here so that when we set it down on a surface, that we're not setting the hot tip down. So see how the tip is suspended there. We do not want to touch this tip. It's going to get super hot. And we don't want to set this down on anything flammable like paper because we could catch something on fire. So be careful. Okay, so I have noticed the timing for this particular thing to heat an area and have it be flexible takes about 7 to 10 seconds. So you'll see me working around this ear over here, heating the plastic, and then I'll be able to bend this ear out a little bit. Okay, that should be long enough. I made sure I set my heat gun down in a safe place. And looks like, yep, it's bending out a little bit. If I heated it up longer, it would be easier to bend it out. The other thing that you want to do when you're doing this is you have to hold it in place until it cools, because it will try to go back to its original shape when it's hot. So I'm going to hold it there until it cools off. You can see maybe a little bit that the ear is tipped out a little bit further this way now. I'm going to give it one more shot. It's important to not overheat it. We're not trying to melt it. We're just trying to make it flexible. So again, kind of depending on how thick the object is or what exactly you're trying to do, you may need more heat. But if you're going longer than 10 seconds, you're probably going too long. So there we go. Now it's coming over really easy. See, it just falls right over, no problem. So I've got my ear tipped out here. I'm going to hold it. I'm actually going to blow in that hole right there to help cool it off. I'm going to give it some time and wait for it to kind of harden it back up a little bit so it doesn't just go back to where it was. And that's our little quick tutorial on the heat gun. Don't burn yourself or set something on fire. So if the filament breaks or runs out, in this instance you can see that there's still a ton of filament there. It just broke during the process. You will get a message that says that the filament has run out. This does not mean that I need to start this build all over again. I basically just need to get the filament back into the print head over here, and it will pick up where it left off.